Alright, so these are today's notes, and what we just did was we graphed the 6 problems at the top of the page. So that was review from what we did last week. So today we're going to talk about solving absolute value inequalities, equations and inequalities. And to begin with, we're going to approach it from a graphic standpoint, so using graphs. And then we're going to do my favorite, which is algebraic, because it's quick and simple. So let's take a look at this. Are any of you guys taking the PSAT next week? Or getting ready to take it? Okay, quite a few of you. And then, will you be taking the SAT this year? Okay. So, on some of the versions, they will have absolute value inequalities or equations to solve. Not every version. But if you work through a practice book, you'll see them. Yes, ma'am.
On the SAT, I just have taken it, and I was wondering, the math that's on there, we haven't learned it all yet.
No,
okay,
we haven't. There are some things that we will do this year that are
hard
on the SAT. Yeah.
But some of the stuff that we have learned this year, like I was able to use it, like imaginary. But like some of it, I didn't see any absolute value on my version.
Okay.
But like on some of it, I was like, wait a second. It was a little more advanced factoring.
Okay, yeah.
So are we gonna do more factoring?
We'll do some more factoring. We will.
Okay.
And then even next year you'll do more factoring. Those of you that are moving on to what do they call that? Pre-calculus. You guys will finally get to study rational functions, which are basically fractions that you would factor the numerator and denominator. And they make really cool graphs. They have asymptotes on there. They might have vertical and horizontal. You can also have oblique asymptotes. But anyway, that's cool stuff. We'll get there. Yes. All right. So the first one is telling us, look at function f. Well, that's our first one right here, right? So where is that function equal to 5? So if we look at this graphically, and this is really hard for me to draw the line, but I'm going to do my best. If we look at this graphically, where is the function equal to 5? So we go to where there's a y value of 5. I completely missed it. And let's see if I can shift that down. No, still missing it. Closer. I'll count it. So where is it equal to 5? So 1, 2, 3, 4, 5. It appears to equal 5 right here and right here. So what are those x values where that function equals 5? Well, one of them is negative 8. And the other one is positive 2.
Oh, so you use the x.
Okay? Now, so what would happen if I took those two x values, negative 8 or positive 2, and plugged them into the equation? Well, if I plugged in negative 8 here, whoops, wrong thing. If I plugged in negative 8, you see I get the absolute value of negative 8 plus 3. The absolute value of negative 5 is 5. Did I get out 5? Yes, I did. If I plug in 2, I get 2 plus 3 is 5. The absolute value of 5 is 5. Okay, let's look at the next one. G of x equals negative 3. So we're going to find the graph G of x, which is here. And we're going to do our best to draw in a horizontal line at 3. Yay, I missed it again.
Okay.
There's nothing at 3.
Sometimes you miss it.
Oh, I do not.
Okay. Okay, so it appears it's right here and right here. So in this one it looks like x, those x values that correspond to that are negative 2 and positive 2. So if I plug in negative 2, I do get out negative 3. And if I plug in positive 2, I get out negative 3. So that would be the solution. This one, k of x, that's this graph over here. We want to know where it equals negative 1. So we're going to come down here and to the best of our ability, draw in 1 at negative 1. So it looks like it's about right here and right here. So my arrows better job. And I think this one is -7.
Yeah.
Okay. And then this one is +5. Okay. Hopefully it's easier to read on your paper.
So that's it.
Okay, so that's how you solve absolute value equations graphically. Now that's handy if you already have the graph. But if you don't have the graph, the second method we're going to talk about is much easier. Because we don't always want to graph things, and we don't always have graph paper handy. But if you have the graph, use it. It's pretty easy. Alright, the second way is to look at the inequalities. So, h of x, where's that one? Oh, right here. Where is that function greater than 1? Same idea. I'm going to come in and I'm going to think about where the y value is +1.
Wait, so this is when you don't have to graph?
No, this is still when you have the graph. Okay? But this one is where is it greater than 1? So it is greater than 1 from here to here, isn't it? Over this interval. So on this section, when it's inequalities, my answers are intervals. It's not a single answer. It's an interval of x values that would satisfy this. So it looks like it's from 2 to 6, from 2 to 6. If we plugged in those values, it would be greater than 1. Now, did you notice I used parentheses and not brackets? Why?
Through that area.
Because I can't include it. There's no equal to. Alright, now the next one we're looking at m of x, which is this one. We want to know where it is less than -1. So we come in here and draw one in at -1. Where is it less than that? So just from here to here. So what are the x values that correspond to that? -4 to -2? Okay. The next one is function n. Where is it less than or equal to 2? So we're going to come here. Now, this one, less than or equal to, is this side and that side. So it's not a single interval. It's 2 intervals. So when I have 2 intervals, what has to go in between? The union. Good. So from -infinity to what is this x value? 3. And then again from this x value to, okay? And you are right. I should bracket that because it is equal to. Thank you. Good catch.
Who caught that? Good catch. Aaron.
Alright. Now, what if this had said this?
7.
You're right, Sammy. It's not. It's never greater than or equal to 7. So what would our answer be? No solution. There is no solution. The function is never greater than or equal to 7. Okay. So now let's look at algebraic, which is truly my favorite way, because graphically, you would only use if you already had a graph. If you already have a graph, graphically works. If you don't have a graph, you're going to do it absolute value equations and inequalities algebraically. So remember, absolute value is a distance. It's the distance from 0 on the number line. Okay, and then last week we talked about how many answers are there to this equation. Well, there's 2 of them. We can do +3 or, not sure what that is. Both of these work because the absolute value of either of those answers is equivalent to 3. So, what if we had this? X minus 2 equals 3. How many different values of x minus 2 can have an absolute value of 3? 2. X minus 2 could either equal 3 or x minus 2 could equal negative 3. Because if this were 3, it would work. And if this were negative 3, it would work. Because the absolute value of negative 3 is 3. So, when we have an absolute value equation, what we do is we break it into two equations because there are two values that work, the positive and the negative. So we just solve these simple equations. So we're going to add 2, and we get x equals 5. We're going to add 2, and we get x equals negative 1. So when we're solving an absolute value equation, every time we're going to end up setting up two equations to solve. Okay, so here's another example. It's got more stuff, but it's the same idea. Before we can set up our two equations, though, first we must get the absolute value part by itself. So what do we have to do to this equation to get the absolute value part by itself? Subtract 8. So we're going to subtract 8 from both sides. Okay, so when we subtract 8, that gives us absolute value of x minus 2 equals 5. So, all of this stuff, x minus 2 can equal 5, or all of this stuff, x minus 2 could equal negative 5. Now, did you notice that I didn't change the sign of anything inside the absolute value? What you change the sign of is this part.
But how does the 2 lines get removed?
Huh?
How do the 2 lines get removed?
When you split it into two equations is when the two lines get removed. So either x equals 7 or x equals negative 3.
Let's try a few more.
Let's try a few more. Alright, so do you see this one? The absolute value is already by itself. So what we do is we take the absolute value equal to the positive, because if all this were positive 5, it would work. And then we take the absolute value equal to the negative, because if all of this equaled negative 5, it works. Because the absolute value of negative 5 is 5. So here we get x equals 3, and here we get x equals negative 7.
Whoa.
Okay, guys, I don't woe me when all I did was subtract 2 from both sides. You're 11th graders.
I was looking like, oh, I was good. I did. I added.
I'm sorry, we've been solving equations since 7th grade.
No, I know. I was just
Okay.
saying. Well, because I got confused and then I added. And I needed subtracted. I made an error.
Alright, you got it now?
I understand.
Okay, cool. Alright, so on this one, we can't split it until we have the absolute value part by itself. So what needs to move to get the absolute value part by itself? Yes, minus 4. So we have the absolute value of x minus 5 equals 2. So now we set up our two equations. The first one, x minus 5 can equal positive 2, and that would be true. Or x minus 5 would equal negative 2, and that would be true. Never change the sign of what's inside the absolute value. What you're changing the sign of is what it's equal to. So here we get x equals 7. Here we get x equals 3. So those are my answers, 3 or 7.
So we have to write out all
When you subtract by a negative, positive.
Okay, so on this one, we have to get rid of the negative 2 first. Okay, so once we have the absolute value part by itself, then we then we can divide it into the two equations. So all of this can either equal 4 or all of this, everything that's inside here could equal -4, and it would be true. So this is x equals 7, and this is x equals -1. Now, I know 7 has been an answer for many of these. 7 is not always an answer. Just by the way, 7 is not always an answer. Okay, so when we're getting the absolute value part by itself, basically when we're solving equations, what do you undo first? Addition or subtraction, or multiplication and division? So if you had this equation, 2x plus 1 equals 9, what would you do first? Subtract 1. So we're going to do the same thing. We're going to subtract the 6.
PIMDAS, guys, PIMDAS.
Well, to solve, we kind of do PEMDAS in the reverse order, the inverse of PEMDAS. Okay, so now what do we do? Divide by 3. Okay. Now let's hang out here for a second. Sometimes we get into what do you call that?
Predicament.
No, when you just do the same thing over and over and over again.
Redundant.
Like my husband, when he leaves our neighborhood, every time he turns right to go to work, so if we ever need to turn left, you have to remind him at the end of our neighborhood. Hit autopilot. Don't get on autopilot with these. That's what I was trying to think of. Because I need you to stop when we get to this point every time and think. Is it possible to take the absolute value of something and ever get out a negative number? No. Now, that's why I said watch out about autopilot. Because sure, could we split this and solve? Yeah, but we'd get answers that were meaningless. We get answers that don't work. There is no solution to this problem. There is nothing that will work. Because I can't take the absolute value of anything and get out a negative number. Okay, so we tend to do that once we learn a skill in math. We're like, every time, oh, I got this. I know exactly what to do. Boom, 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 boom. And we just kind of push through. Make sure before you keep pushing through, you stop and think, is this possible? As long as this is a positive number, your answer is yes. Keep going. If this becomes a negative number, stop. You're done. All right, so inequalities, they're going to be very similar. But remember, when you multiply or divide by a negative value, what happens to the inequality sign? It switches the inequality sign. And in this case, we're going to switch the inequality, and along with that, we change the sign of the number. Okay. So, for our first inequality, it's going to always stay exactly the same. All we're going to do is drop the absolute value symbols. For the second one, we change both the inequality, we switch it to the opposite. So it goes from less than to greater than, and we change the sign of the number. Now, okay, we're going to take a kind of a throwback timeout right here. And in 7th grade, you started talking about inequalities back in elementary school. Greater than and less than. Yes, you did. I've been helping my son. So you compared numbers, and you called it the alligator. And what happens is, when we call it the alligator, we don't actually learn the proper term for the symbol. And so we look at them and we're not sure if they're less than or greater than. So this is my little trick that when I taught 7th grade that I use with my 7th graders. We all put up our left hand. Join me. Okay? So if you see the left hand makes an L. Alright? And so this is what we do. We go left hand, less than. Left hand, less than. Left hand, less than. Okay? So your left hand, oh, that's much more exciting than what I was doing. Your left hand the less than. The left hand makes the less than. So if just the terminology is making you stumble, that's a good way to remember. It's almost impossible for the left hand to make a greater than unless you're double jointed like me and you can flip your hand around. And some of you are.
Wait, do it again.
The
Double joint.
so that's left hand and then
What?
some of y'all can kind of do it. That's cool.
Right?
Alright, so here's my stupid human trick for the day. And this is why the golf pro kicked me off the golf team after the second year and said find another sport. This is normal. This is normal holding a golf club. This is me.
That doesn't look
Is
right.
that just natural?
It's really hard to do normal.
Oh, God.
Normal hurts.
That like hurts?
Then I had a wicked slice, and you can see why. I couldn't. It would break. It would break. It would break here. It would break on that. Can't wait. All right. So now we got our left hand, our less than, and we know who's double jointed. So this is fun. All right. Is this one possible before we get started? Because it's just the absolute value. Yeah.
Yes.
Absolute value is greater than a positive number, so we're good. All right. So let's start to solve it. The first one, we just drop the symbols, and it stays the same. The second one, we change the inequality, and we change the sign of the number. Now, this is a greater than, and what we're going to discover with greater than is that they kind of go away from each other. If we graphed it on a number line, which we could see on the PSAT, SAT, whoops. I know this isn't straight. I'm trying. It's probably still not, but it goes this way. It goes away from each other. It would go this direction, remember graphing on the number line, and this direction. So it is not coming together. The answer would be greater than 6 or less than -2. Now look up here, what word did I use?
Yeah.
And. So when we're solving a less than, we're going to get an and situation. And when we have and, we can write our answer as one simple interval. When we're solving a greater than, what's going to happen every time is it's going to go in opposite directions. That gives us an or. And we end up with 2 inequalities as our answer, if it's something that we can solve. So greater than go apart. This one, we didn't solve this one, did we? This one comes together. All right, let's take a look. Let's go back. This would be x is less than 5 and x is greater than -1. Do you see that it does come together? If we graphed all the solutions that are less than 5 and greater than -1, it would be from here over to here. And so we could write it as a single interval from -1 to 5. And that was just, oh, those were less than, so I should not have filled that in. I'm going to cheat a little bit. I'm just going to white it out. There we go. All right, this one. Oh, I didn't write the interval. The interval would be from -infinity to 2, union with from 6 to infinity. So these are 3 different ways of presenting the answer. So if you took the SAT or PSAT, I really think you'd see this first or this second method. Now, if you're going to pre-calculus, you need to know the third. Okay, if you're in Miss Louie's class right now, you need to know the third.
Oh.
Okay. All right, this one. The The first thing we have to do is to get the absolute value by itself. And then we make sure we're not on autopilot. We look at it. Is it possible for an absolute value to be greater than or equal to 5? Yes. Will this answer be 1 interval or 2?
2.
2, because it's greater than. Very good. So we're going to solve the 2. And we know it's going to be an OR. So here we get x is greater than or equal to 2.
And why would it be a,
Okay, so that's 2 answers. Less than or equal to -8 would give us this. Greater than or equal to 2 gives us this.
Okay, I got it.
Okay, this one we would divide by the -3. I am taking an inequality and dividing by a negative. What is my result? What's going to happen with my inequality? Good. It changes it from greater than to less than. Left hand, less than. Okay? This is a less than. It's going to come together. It's going to be 1 interval when we're done. So we split it here. Okay, so we get x is less than or equal to -2. X is greater than or equal to -6. Goes from -6 to -2. It comes together on the number line. Oh, thank you, brackets. You're so right. All right. The homework sheet. If you're busy tonight, you can save it for tomorrow because tomorrow is a workday review day. Tomorrow is a workday review day. Yeah, you'll get a review sheet tomorrow.